I'm going to go over both the notebook, more on pandas, as well as the separate set of questions that were your actual assignment. So this was just meant to introduce you to a couple of elements about pandas. So the first is I wanted to show you the difference between a pandas series and a pandas data frame. And a series is really just a list of numbers or of texts, pieces of text or dates, as long as they're all the same kind of object. In a regular Python list, you do not have to restrict yourself to all being the same object, but in a pandas data series, they all have to be the same, because part of the advantage of them is that you can use certain kinds of operations across the whole series, or what's called a vector operation, and so that it does it very quickly. So for example, if we have the series where we created a series out of this list 1, 2, 3, 4, 5, and we said, okay, series equals series to the power of 2, it creates a new series for us where every element here has been squared. If I said series to the power of 0.5 and I ran that, I would get the square root of every single one of these numbers. This operation actually is very fast, and so that's one of the reasons that it's advantageous to use it. When you get to a data frame, so here we created 3 series, the name series, the age series, and the city series. Then we put them all together and we created a data frame. We then renamed the columns here, and when we look at what we have, let's take a look at that, we can see that, sorry, it's data, that what we've done is we've created a data frame, sorry, it is df, and what that consists of are 3 columns. Each one of these columns is what was defined as a series up here. So we can take multiple series, put them together. Each series would represent one of the columns in our data frame. What I did here was I renamed columns. I renamed the column name to person name, and I said in place equals true. Whenever you see this, what it means is that rather than creating a new data frame that's a copy of the original but with the column name changed, what this does is it goes to the original data frame and updates it. And so df has now been changed. If I had not had in place equals true here, and I had run this, then when I ran df, you could see that the column name has not changed. It's remained name. But what I would have had to have done was say something like df new is equal to df rename, and then that would have created a new data frame that would have been a copy of the original, except that the column that was originally name would have been renamed to person name. So in order to avoid having to create a whole new data frame, I have the in place equals true, and that means that it updates the original data frame. And so when I run that, I don't have to define a new data frame. It's just changed my original data frame. Okay. This command, by the way, is very useful if you are trying to read in, let's say, something from a Wikipedia page that has a bunch of tables in it. What happens is when we read it in, what Pandas does is it goes through the page, and this was a list of different, this was a page that had different lists of Standard & Poor's 500 companies, like large companies. And what happened was that it created this thing called the SP500, and SP500 is a list of all the tables in the on that page. And so what happens then is we say, all right, let's make a data frame that we get from the first table that was on that page. So we say tables, which is our list, bracket 0, and when we do that, we have a table here that was pulled from that web page. Now, I don't know how many tables are on the page, but if I had said SP500 equals tables bracket 1, then I get a different table here that was the next table that appeared on that page. So what you want to do is go see what number table you want to use from the Wikipedia page, and then you'll use 0 for the first, 1 for the second, etc. And then when you read this, it automatically just creates a data frame. And so we created a data frame called SP500. It has 500 or 503 companies in it with these columns. Okay, so what I did here was I don't want to really go over. You don't need to know this. Read over it. But what I wanted to show you was here. So for exercise A, what this is doing is it's saying, okay, we have this data frame called DF large. It's missing some records. And this is DF large here. You can see that there's 100 records, but column 1 has only 81 records. Column 2 is only 85. So what I wanted to do is I want to drop the records where in either column 1 or column 2, I'm missing values. And so when I do this, and I again use the in place equals true, and if I then say df large.info, you'll see that this new data frame, df large, only has 70 records now. And that's because any record that was missing a value in either column 1 or column 2 was dropped. And that's because I put how equals any. If I said how equals all, it would have done it differently. What it would have done was it would have said, I'm only going to drop the records where it's missing records in all of these columns here. And so when I do that, you can see I end up with 98 records altogether, because only when it was missing in both column 1 and column 2 would it drop it. When I had any here, it would drop it if it was missing either a value in column 1 or column 2. Okay, occasionally what you want is you want to replace values where you are, when you're missing values, let's say we want to just replace them with the mean value of that column. So right now, we'll go, but let me put this back to any here, which was the original. So at this point, column 3 is missing 22 values. And so what we want to do is we want to replace the missing values with the mean of the remaining 78. So what we do is we do df large column 3, and then we do this fill in a thing, and the value is just equal to the mean of that column. And again, we're not creating a new data frame, we're updating the current data frame. So when I run this, and now when I look at df large.info, what happens is that I now have, you can see that column 3 now has 96 values. So there were 96 in our original data frame, or at least this version of it. And so we now have 96 values in column 3. So it updated column 3 to replace missing values with values that are equal to the mean of the values that were not missing. Okay. All right. So moving along, so here we created 2 series here. And again, a series we can create just by putting a list of items inside parentheses. And then we created a data frame from these 2. And so when we run this and we look at df type, here's what we have. So A, B, C, D, E became the first column here, 23, 44, 33, 10, 88 became the second column here. Okay, so now what we want to do is we want to convert column 2, which is currently a text, and the reason is because we had all these numbers were in quotes. And so that means if we try to do something like figure out, all right, what would be the mean value of the values in column S2, and because that's a numeric calculation, when we run that, we actually calculated that for us. All right. All right, sorry about that. So what you can see is when we asked it to calculate the mean of this column, we got this totally bizarre result here, which clearly is not correct. But what we can do is we can convert, and the reason is because these are not numerical values. So I don't know how it calculated this. But what we can do is we can convert df type, the data frame column S2, into, we can say df type S2 as type int. And what that'll do is it'll convert it from a string character into a numerical character. And then when we run mean, we get 39.6, which makes a lot more sense given the values that we have here. We may often have to do something like that. Okay, this next thing is we've looked at how you can look at the first 10 records, the last 10 records using .head or .tail. Well, now if we use .sample, it just picks a random sample of 10 records from our data frame. Okay, we want to convert the values in column type to all uppercase. So we're going to start with in our data frame, we have its df monument type. And what we want is, we want to say equals df monument type dot str, and that's because we're using the contents of this column, and we're telling Pandas we want to do a string operation. And so we would do upper and then open paren, close paren. And right now, if you look at type, you can see it's a mix of upper and lowercase, depending on, just normal capitalization. So when we run this, if we now look at df monument, we can see that the type is now all uppercase. You might want to do that in some cases where if we're trying to determine if two strings are equivalent, if we convert it all to all uppercase or all lowercase, it'll make it a lot easier for us if there's consistency and we're not worrying about whether two strings are not equal only because one has uppercase letters and the other doesn't. Okay, we want to create a new data frame containing only the records where the name of the artifact column contains Robert E. Lee. Okay, so here's what we're going to do. We're going to say, okay, in artifact, what we want to say is we're going to create a condition, and we're going to say condition equals, and it's going to be df monument, and then we're going to enter the name of the column that we're interested in, which is the name of artifact. Trying to get this correct here. And what we want to see is if somewhere in the name of the artifact we have the word Robert Lee. So again, we're going to use this .str, and then we're going to use .contains, and we're going to have Robert E. We're asked for Robert Lee, just Robert Lee. Okay. And so what we'll do then is we'll then say, okay, df, we'll call this, let's say Lee, equals df monument, and we'll apply the condition here. Okay. So when we run this, we get an error. And the reason that we got this error is, let me investigate this. Okay, the error we were getting was because name of artifact, that column has some missing values. So what I did first was I dropped those from the data frame, and now I can look only for the columns that contain in df Lee. We'll say these are all the artifacts that contain the name Robert Lee. So we've created a smaller data frame, and you can see it just has these records, and these are all artifacts that have the name Robert Lee exactly in them. It might be that some of them contain Robert E. Lee, perhaps, and we could investigate that. Nope, so it was Robert Lee. Okay. All right, so going to the actual questions that you're being asked, the relationship between a Pandas series and a Pandas data frame is what I explained before, which is that a Pandas series is a one-dimensional list of objects. They all have to be of the same type. And a bunch of series put together will make a Pandas data frame where each series will be a column in the Pandas data frame. Okay, what vectorized operation would create a new series containing all the values in A but raised to the power of 3? We could say A3 is equal to A, and then we just have to say to the power of 3. Although in Pandas it would look like this. And this would give us a series where it would be A3 is going to have the values 1, 8, 27, 64, 125, where each of these 3 numbers, or 5 numbers, has been raised to the power of 3. The difference between these two here is that this is going to create a new data frame, but since we didn't say something like df new equals, it's not going to save that data frame. So when we run this first thing, we're going to see this change, but it's not going to be kept. Here, what we do is we say in place equals true, and what that does is it goes back to the original data frame and it changes the name of the column, which was originally name, it changes it to person name. Here, this is not going to change anything in the original data frame because we don't have the in place equals true. Okay, to show 10 randomly selected records from a data frame, instead of df.head parentheses 10, we would have df.sample parentheses 10, and that would give us just a set of 10 randomly selected records. Okay, how many unique values are there in this? So we would start with the name of the data frame. We would then enter in the GICS sector column name, and then we would do value count. And what that's going to do is it's going to count the number of unique values that show up in this. So, different companies belong to different sectors, and this will show us how many are in each of the different sectors. Okay, so create a filter mask that would filter in only those records where the GICS sector is equal to healthcare. So we would start with this same thing here. And we would say we're going to make it a condition, so we'll call this condition 1 is equal to, and then we'll say it's going to be, we only want those records where this column has a value equals to. If we don't use the 2 equal signs, it's not checking equality. What it's going to do then is it's going to change every single of these column values to healthcare. So we want to make sure we use the 2 equal signs. And what this will do is create a filter that will include only the records where the sector is healthcare. And then if we then want to apply that, we would say df HC for healthcare equals SP 500. And then in square brackets, we would just put the name of our condition. And that would give us a new data frame that contains only those records that meet this condition here. Okay, what would change the name of the founded column in SP 500 to founded date? Well, if you go back to our data frame, if you want to change the name of a column, you use this thing right here. And so this was to change the name, except here we would have to replace the df large. Sorry, this is the wrong thing. Let me go back to that. Get the rename a column. Well, it's somewhere in here. Oh yeah, here it is. Okay. Here's how we rename a column. So we would have something like this, except we would have to change DF to SP500. We'd have to change name to founded, which is the original name of the column, and then we'd have to change person name to founded date. All right, what does the command setIndex do? What this does is it recreates an integer index for every record in the data frame, and sometimes we need to do that because we've been using a group by command and we've created a sort of strange index. Often you want to use it when you're creating a new data frame from a group by command. Okay, so for exercise A and exercise B, exercise D, exercise E, I went over that back here. And so you can just go back to the earlier part and look at what I did for each of these.